One of the contributions we made at the time, for instance, in this area was how can you use imaging to identify how the brain of a patient is getting atrophic over time. We saw the convergence of imaging and AI at the forefront of the revolution.
Yeah.
We are championing a new research area at the moment, which is called AI for AI.
歡迎大家嚟睇呢個肥胡醫療嘅節目。今次咧，我哋有一個大突破啦！坐喺我側邊呢個咧 ，Professor Ourselin 咧就係頂呱呱嘅一個醫學界嘅大名人。佢喺呢個用AI 幫助嘅機械人啊、腦裏邊啊各種嘅 imaging 咧，都係全世界有名嘅。咁啊，今日我哋好開心請到佢嚟幫我哋做一個訪問。Welcome, Professor.
Thank you.
First time to Hong Kong?
Second time.
Second time Hong Kong. How do you like us?
Oh, I love Hong Kong.
You love Hong Kong?
Yeah.
Oh, you have to come back more. Professor, now, first of all, when I saw you, I didn't realize that you're so young. You're such a renowned expert in imaging and biomed technologies. Now, can you tell us something, the things that you have done? And you have done so much. I read your CV, and you have done so many breakthrough researches in the world. AI-assisted robotic surgery, especially the neuro side and cardiovascular, everything. And maybe you tell us.
Sure. So I've been in this domain for more than 25 years. I'm an engineer by background.
Yeah.
I study mathematics and physics, and I've always been passionate about applying those knowledge into medicine. And so I put my service towards neuroimaging at the beginning and neurology. When I developed imaging biomarker to assess efficacy of drugs, especially drugs to try to fight disease like Alzheimer. And then I apply some of those same techniques in the context of neurosurgery. Did quite a lot of work in collaboration with industry in the treatment of epilepsy, for instance. How we can develop new technology to curate patients with epilepsy by resecting the brain very accurately.
Resecting the brain?
Resecting the brain.
How do you do that?
Yeah. Well, you do that very carefully, and you do that using very advanced surgical planning solutions that are based on medical imaging, diagnostic imaging, like MR scans, where you can combine the knowledge of the anatomy with the knowledge of the physiology and the understanding of where the epileptic seizure is coming from in the brain. And we have ways of doing this using electroencephalography, and some of the most modern techniques are quite invasive when you try to identify the best position in the brain, the best location with an electrode. And so some of the work I was leading was about how can you identify what are the best spots to insert this electrode, and then you can do the reading in the brain. And once you know exactly which part of the brain is affected, then deliver a robotic solution to improve as well how you can cure this patient by resecting the specific part of the brain only.
Well, you mentioned about Alzheimer, which people like me is very worried about. What is your take on Alzheimer these days with robotic or AI-assisted robotic on Alzheimer?
I'm not
resetting the brain.
Yeah, I'm not a neurologist. I think I should be quite careful about my take on such an important neurodegenerative disease and public health concern. However, I mean, there is some breakthrough right now in the efficacy of some drugs, especially trying to target the amyloid plaques. So A-beta, the amyloid in the brain, the protein has been demonstrated as being really linked with some of the long-term effect on the patients, especially this accumulation of this protein in the brain will usually end up by those patients having some memory impairment, and then we can hopefully try to identify those patients early and treat them with those drugs. So one of the contributions we made at the time, for instance, in this area was how can you use imaging to identify how the brain of a patient is getting atrophic over time more quicker than a patient who is healthy. So how do you compare healthy aging with Alzheimer and use this as a diagnostic tool to eventually identify very early on the the disease. And the early you can identify the disease, hopefully, the more you can treat it.
That's a solution.
Exactly. So it has been a very challenging area, Alzheimer, compared to, for instance, I was mentioning before, epilepsy or even Parkinson, which is another area that I work quite a lot on. Alzheimer has been really, unfortunately, victim of not having any drugs working for many, many years. Now we've got a drug. It's one of many, hopefully. And therefore, all the tools related to advanced imaging, advanced AI for early diagnosis will become reality and will become really an important tool for clinicians to diagnose the disease early and then eventually treat it.
Now, you said you have been in this profession for 25 years. In the last 25 years, imaging and robotic and AI assisted have come a long way.
Very long way.
Maybe you can describe to us what have you seen over the last 25 years, from a simple X-ray now to AI-assisted robotic surgery and everything.
If you're thinking about 25 years ago actually is not that far away. I mean, diagnostic imaging has been around for a long while. So X-ray, CT scan, so ionizing imaging has been there for, as nearly over than 100 years old. So when you look at MR, which has been really revolutionary, it has become really a diagnostic imaging solution, which is used now as a commodity. If you become a patient at some point, diagnostic imaging will be part of any of your pathway. In the past, it wasn't the case. So even 25 years ago, I don't think we will expect most of our patients to get an MR scan. Now, most of the patients, if you have a disease, will actually get an MR. So I think what we've seen over the last 25 years is the acceleration of the uptake of imaging into the clinic. Indeed. Acceleration of the uptake of MR in particular, and the usage of higher field strengths, which give you more power, more strength, and therefore more contrast, and more refined images. And what has been quite remarkable over the last perhaps only 2 to 3 years is the change of direction in the field, where now people are looking back to low field scanners at much lower power.
Why?
And they've been doing that for the fact of trying to get this technology becoming a commodity. So if you're in a fantastic hospital like one of your hospitals in Hong Kong, then people will be able to afford a 3D scanner. What's about the rest of the population? And it's quite striking to see that 90% of the population in the world don't have access to an MR scanner.
Correct.
So in this context, what do? Do you bring more of those scanners, which are very expensive, which require a lot of very rare gas,
that's right,
which needs to be refilled, which needs to be maintained? Or do you go to try to develop the same capability at a lower cost by reducing as well the weight of the scanner, that the scanner could eventually end up at the back of a chemistry or a pharmacy? And to do that, what you can do now is combining the power of MR with the power of AI to increase the quality of the image on a lower field strength, which means a scanner which costs less to manufacture, and get image which will be as good as what you will get on a 3D.
Quality.
Exactly. What you get is a scanner which, as I say, is a lower weight, which is just as good, which doesn't consume any rare gas. And you can have this scanner on the basement of an hospital. You could get it on the 4th floor. You could get it in the back of a clinic. And so by having this versatility, then hopefully those scanners will become a commodity. And not only you can get them in Western economy, but you could get them as well in Africa or other places where we cannot right now afford such machine. That's really where I could see a huge change in term of the way that the MR market is moving. We are the first in the UK to actually acquire one of these low field machine, and to be able to demonstrate the viability of it and how you can combine with AI, which really became so powerful due to the explosion on computer power and all of this graphic processing unit, combined with access to large amount of data, a vast array of data, which enable you to get training on your data set, with this data set, which enable you to actually improve the quality of those images.
So AI is actually very important in the development.
Absolutely. I think we saw in medical imaging, but in surgery as well, we saw the convergence of imaging and AI at the forefront of the revolution. And if you now add on top of this all of the amazing progress in robotics, then I think those three pillars are intersecting and are really creating the next generation of not only diagnostic imaging, but as well surgical solution.
Now, there's an old Chinese saying, is prevention is more important than cure. Now, in the imaging or in all this AI-assisted technologies, can we predict that in fact there will be a lot of earlier detection in the future, like cancer?
I will agree with Chinese philosophy that prevention should be key. I must confess it has been very difficult for any healthcare system to make it happen, as I'm sure you know, because usually it's hard to implement because it's a public health issue.
Yes, indeed.
Preventive health does require change of behavior as well.
Absolutely.
And if change of behavior is not happening, then you might have the best program of prevention.
People just don't do it.
People will not do it, right? Like not giving chips and Coca-Cola to your 2 years old. You know, can prevent a lot of potential issues in terms of obesity and diabetes and so on. How many people will actually implement this? But if we go back to Alzheimer's disease, for instance, if you were able to detect it so early that there is no cognitive decline yet, you don't have any sign, your brain has not been affected. It's just early accumulation of beta amyloid plaque in the brain, let's say. And if you had the drug right and there, ready to go, then you know it will be a fantastic achievement for everyone.
Now, a lot of people are now trying to compare the blood test with imaging. Because in the old days, you just do a blood test and then you do a lot of imaging. But now the medical technology actually on the blood test is actually quite advanced, right? That give you a lot of markers.
Totally. So I will say you need to be holistic in the way you look at your data.
Holistic is the word.
And this is really where I think AI again will become a very powerful tool. The challenge of combining data coming from different markers has always been a challenge because some markers are much richer, much larger. Let's say your full genetic information compared to a single blood test, or compared to a 3D image of your brain. How do you combine those data? So it's a big field, which now people label on the multi-omic, when you are combining genomics with proteomic and imaging. You can combine it with other information coming from the patient of the kind of wet biomarker and blood test. If you need to do that, or if you want to achieve this, you need to be able to link your data together. You need to be able to label them. You need to be able to curate them. You need to be able to do that at scale. And that's where the revolution of AI is fully aligned with the revolution of electronic health record. So, you know, lot of investment now in many hospitals are going towards having an implementation of an electronic health record of the kind of EPIC that become very, very common now in hospital, which enable you to make sure that all your data are electronic. Still a lot of data sets right now are paper-based. Go back to your prevention. If we really want to prevent, you need to have the full history of your patient, all electronic, from your birth. And then you can see evolution, and you can start to assess potential challenges or potential side effects of a drug that you've been taking for 10 years that were told 25 years ago this drug was safe and it was put on the market, but we never saw that this drug combined with another drug or combined with some of your health condition might provide you comorbidity. So this is really where I think AI is going to become so powerful.
Like in Hong Kong, I mean, the government has implemented this electronic health record, so put everything digital. But then the data farming and managing is creating a big problem because having data is one thing, but having data in the right form, in the right format for AI.
So we are championing a new research area at the moment, which is called AI for AI.
AI for AI,
which is how can you use well-curated small data sets to learn how to curate data at scale without human interaction. So if you do that, you can apply artificial intelligence to prepare your data and then to be in a position that you can build the best model which will target the most important healthcare challenges. If you talk to data scientists, they will tell you they spend 90% of their time preparing data. Link them, clean them, annotate them. If this part could be done automatically, that's something which could be done behind the scene. And that's another situation where I think AI will definitely make a huge difference to the way that we can use those data.
I see. What took you to Hong Kong, sir?
Well, I came to Hong Kong to formalize a partnership with CARE, a Center for Artificial Intelligence and Robotics, which is part of the Chinese Academy of Science.
Which is a top Academy of Science.
Which is a fantastic university. We have actually set up a new laboratory between King's College London and the Center of Artificial Intelligence and Robotics. To work together and to co-create in the domain of AI and robotics in surgery, specifically, to be able to advance some of those surgical robotic solutions together and take advantage of the very strong push of the Hong Kong government towards science and technology and driving a next economic chapter in this area in Hong Kong. So I think it's a great opportunity for us to partner. It will bring critical mass at a time where I think Hong Kong needs support. It will bring as well an opportunity for us to reach Asia, to contribute to the Hong Kong economy. And to the medical sector and the industry sector. And as well, I think it's going to help to create even more workforce in those domains, working closely with the local universities, training more engineers, more computer scientists, more roboticists who will end up contributing to the Hong Kong economy. I'm really excited to actually have an opportunity to be part of that and to contribute. And we want to bring a bit of London into Hong Kong, and hopefully we'll bring a bit of Hong Kong into London. So on one hand, personally we spend time in Hong Kong to support the strategic development of the laboratory. But as well, we anticipate that our students, our research fellow, our postdocs, but as well our academic, will spend time in both sides. So colleagues from CARE will come to London. Colleagues from London will come to Hong Kong.
So there's a big exchange of talent
to be able to co-create technology on both sides of the globe.
Thank you very much, Professor. It's such a wonderful time talking to you, and hope you come to Hong Kong more often. And we love to see you here. 多謝大家收睇肥胡醫療，我哋下一集再見。